Okay, so like we were saying, we get this substituted in here, and now we need to simplify. There's several things that we need to consider for this, obviously, as you guys know. We need to simplify these units right here, and we also need to consider our significant figures. So we're going to go ahead and do that. So as we simplify this, we're going to go ahead and multiply by the reciprocal to eliminate, to get this so it's, I'm going to show that out. So if you have amps over 1 times, now I'm going to do the reciprocal, ohms over 1. So what you end up with is a unit of amp ohms instead of this. This is a little bit confusing here. So let's also consider significant figures. And in this case, actually, we don't have the actual data table to do that from, so we're just going to go ahead and leave it as this for now, and we'll discuss that in class. If you have any problems, you have that in class. So what we get for our final equation then would look like this. Current equals 121.4 amp ohms times 1 over R minus 0.1832 amps. And again, I can't consider significant figures without the actual data table itself. So let's go ahead and look at the PowerPoint here. And your final equation is already up there on the board, so you can go ahead and fill that in for that slide, or you can pause it here if you need just a little bit more time. Okay, in words, what this means is current is inversely proportional to resistance, right? As the resistance of the lamp increases, the current decreases. It didn't change that variable as you look at that equation. It's still the same thing, even though it looks linear now. We're using our mathematics to help us so that we can come up with an equation. It's still linear. Or it's not linear, it's still inverse, even though it shows a linear thing. Okay, just disregard this first part here. The other thing that we want to consider is, does it make sense to drop the y-intercept? You always want to consider this, even if I don't ask it. You always got to consider this. So the y-intercept may be dropped when the absolute value of the y-intercept is less than 5% of the slope, and if there's logical sense to drop it. Okay, so let's go ahead and consider that. The absolute value of the y-intercept is 0.1832. So let's consider that as a percentage of our slope. So let's come back up here and go over that. So 0.1832 divided by 121.4. Clearly you're going to see this as less than 5%. And as far as percentage-wise goes, let me get the official, using my calculator here, let me go ahead and calculate that out. 0.1832 divided by 121.4. Okay, so that gives us 0.15%. Okay, if we were dealing with money and that we had a dollar, 0.15% would be less than a penny as far as that goes. And so you can see that there's not a whole lot there. This number here does not affect your overall. It's just so it's negligible, and again, and from the statistical standpoint. But we also got to look at in reality what this actually means. Okay, and this is going to get a little interesting, being that it's an inverse fit. It's not like a linear fit. It gets a little bit more complicated. So let me show you that. So we should drop the slope in this case if the line should go through 0, 0. Okay, so I got to go back a few slides and see what this means. Okay, so here's our 0, 0 point right here. And you got to know a little bit of background about the information here to know if we should do this. So y-intercept, let me show you. So it's this point right here. It's the value of current when 1 over resistance is equal to 0. All right, so let's look at that. So our mathematical definition is the value of y when x equals 0. And you'll remember this from the other lesson we did last Friday actually. And so it's the value of y when x. So let's substitute that in. It's the value of current when 1 over resistance is equal to 0. So 1 over resistance. Now this is going to be fun for you pre-calc students and you calculus students because you don't really talk about this a ton in algebra, what this is. So what does the resistance, the question is, what does the resistance have to be to make the number come out to 0? It can't be really small or it'll blow up into a big number. So the resistance when 1 over infinity, when you take 1 divided by infinity, that will approach 0 like that. And so the value of y, when your resistance is infinity, that gives us 0. So that would be an inverse. In other words, it's showing that when you have an infinite amount of resistance, you should have very little current. Now, in a wire standpoint, you don't necessarily know about that sort of thing yet, but that makes a lot of sense. If you're thinking about electricity and there's lots of stuff in the way, more and more resistance, then there should be less and less and less current. So in this case, it would make sense to get rid of it because we want our resistance to be that number right there. Okay, so it makes sense in reality to go ahead and drop this. And that's the kind of thing you want to think about as you're doing these things. Okay, so let's come back to the final equation. So you can actually write this equation out without a y-intercept. And so I would actually write this. This would be your final equation here. You don't actually need the y-intercept at this point. So there you go. That's your final equation. Right there. Now, saying a fit fits better or does not fit better is not very statistically significant. So there's another thing you may have noticed on Logger Pro. There's another there's a couple other things on there besides slope and y-intercept. So let me show you that here. So the question is, how do we know if we get a good fit? More than just it looks good. You can't use that. That we need to use scientific terminology and an actual number for that. And the number for that is actually correlation. And I'll show you that in a second when we go back to our Logger Pro. So the correlation is a number between +1 and -1. It's the extent to which the two variables are correlated. So a +1 correlation would mean that they are very correlated. In other words, they're very related. 0 would mean they're not related at all. Okay? So a perfect correlation is shown by a slope of +1. If it's a negative slope, it'll be a -1. Okay? So while we do real data, when we actually do real data, that won't hardly ever happen. But it's always something to shoot for, especially as you're trying to make your fit statistically acceptable. So let me show you that here. If I go back all the way to the beginning. Okay, when we did this fit here, if you notice here, here's where it says the correlation. -0.85. It's not the negative that makes it not a very good correlation. It's the 0.85. Now 0.85 might be at times the best you can get. But in this case, it clearly shows a trend and the correlation is low. That is not a great correlation, 0.85. Okay, now let me show you the other correlation. It's here, and there we go, 0.9995. That shows a much better correlation, statistically showing that this is a much better fit. And visually it lines up as well. So that's how you want to prove out whether you have a good, whether the strength of your fit is. So as we go into the assignment tomorrow in class, you'll want to make a note of that correlation because some aren't always going to have the same answers. And so you want to make your argument based upon, as to whether you're correct or not, based upon that correlation number being close to +1 or -1. Okay, and I think we have just a few slides here. Perfect correlation with a negative slope is shown by -1. I just want to make sure you get that into your notes there. Okay, and then there's the comparison between the two fits. I already have done that. So negative 0.85 and 0.995. And yes, this confirms what we already know, like we just covered. Okay, so in review of how to do this, this is your step guide right here. You have this in your notes. You need this 5 steps in that yellow sheet that I gave you, and this will help you get through any of your problems. Before you ask me a question, I will ask you a question back. I'll say, have you gone through these 5 steps? And then I'll ask you, what step are you stuck at, before you even come to me with a question. Okay, so here it is. Locate curve fitting, that yellow sheet. Flip through the pages and find the graph that appears to be similar to yours. You can play that game that I do on Sesame Street. You can even sing the song if it helps. One of these things is not like the other. One of these things just doesn't belong. So it's a fun game. So make it fun. Don't just like, you know, oh, this is boring. No, just make it exciting for yourself. Then straighten the graph using Logger Pro. Again, we're going to do a tutorial number 3 on that when you get to class. Find the mathematical equation, substitute the variables, and check your new fit looking at the correlation number. A lot of stuff packed into a short amount of time there. So we're going to just really develop this. It's a skill that you guys just have to do practice with as we do worksheet, I believe it's number 4. So anyway, have a great night. Thanks for tuning in, and see you next time. See you tomorrow.